On the nonmetals lab, we didn't have calculations, so most of what we're wanting you to learn is about the nonmetal compounds or elements that you're making. And you will need to match those with the reagents that we use to make them. These reagents, we either added an acid base or a catalyst usually to those to get our nonmetal products. Know that our nonmetal products are gases because things that are small and covalent compounds are normally gases at room conditions because they don't have very strong attractions between molecules. So before I go through the questions, I'm just going to go through the reactions and I'll tell you some properties about each one as we go. As I go through these, kind of watch for the hints of what reagent makes what nonmetal product. So I'm going to put the nonmetal products over here. And you don't have to memorize the whole chemical reaction, just kind of be able to match the reagent in blue to what is made. This first one, it has ammonium chloride, and the product that we're interested in is ammonia. That's the gas that is produced. Ammonia has a strong pungent odor. It'll burn your nose. It's like if you smelled a really, really strong cleaner for a floor or something like that. But even like Windex has a dilute, can have dilute ammonia in it. The thing that's different about this non-metal product, it's the only one that when dissolved in water forms a basic solution. So it turns pink litmus blue, and it's the only one of these. Okay, the next one is, if you look at this H2O2, you can kind of pick up on that as your hint that oxygen is the product. This is hydrogen peroxide, and hydrogen peroxide in the presence of a catalyst will decompose, and one of the products is the gas water or oxygen. And as you might think, it's not, doesn't have an odor, it's not acidic or basic. But what this reaction is known for is its strong effervescence. In other words, it really bubbles. And you know this because when you put hydrogen peroxide on a cut, your blood supplies the catalyst and you get that fizzing. That's oxygen being produced, which helps kill bacteria. Okay, this next reagent, the potassium nitrite, we actually did two reactions with it. One of them was with sodium sulfamate. And this just made nitrogen. And so it's, pretty doesn't have a color. None of these have a color so far. It doesn't have a smell. It's neutral. It has a mild effervescence. So this is the one that you may have seen a bubble or two. So not a whole lot to go on with that one, but sodium sulfamate. Luckily, we did another reaction with that one, and it's a little bit more interesting. It makes two compounds that are mixed. And these are a little bit easier to spot because they have a color. The gas does, yellow or brown gas, and they have a sharp odor. These were very unpleasant to smell, burn your nose, and also they are acidic. And there are several that are acidic, and I'm going to show you the next few together because these three are kind of similar, and so you can kind of memorize these together. If you look at the formulas, you can kind of tell what they're going to make. Okay, and you may know carbon dioxide is odorless, colorless, so that's not interesting. What is interesting about it is that it does form an acidic solution. And then this SO2, its smell is pretty well known. It's like burning sulfur. It can smell, you know, like matches is what one way to just describe it. It is also acidic. So these three, like I said, they have something in common in that their formulas look kind of the same, and the pattern looks the same, but they are all acidic. Non-metal oxides form acidic solutions in water. So know those. There is another one that's acidic too. It'll be more obvious that it would be an acid. But anyway, so those three. Okay, thioacetamide does a reaction with acid where it makes a very unpleasant compound. This is, when it's dissolved in water, it's called hydrosulfuric acid. We could just call it dihydrogen sulfide if it's not dissolved in water. But anyway, you can tell that because its formula starts with H, it's acidic. It is an acid. But what it's known for is its smell. It smells horrible. The description we usually say is it smells like rotten eggs. This is the one that we did in the hood. Okay, and these last two kind of go together as well. These are the ones we did in the large test tubes, and you can tell from their formula what they're going to make. So one makes bromine gas and one makes iodine gas. The bromide gas, of course, it's brownish, maybe brownish yellow. The iodine gas, we call it violet. And let me move this over. When it's put in, let's see, if this is in water, if it's dissolved in water, it's still brown. If it's dissolved in hexane, it's yellow. The iodine, it's brown in water, but if you put it in hexane, that's the hexane we added and we got that different color on top, it's violet again. It's really pretty. And then to know about these two, we say that they have a halogen odor. But that kind of gives away what it is. So we may say they are sharp, or we may say that they smell similar to chlorine or Clorox or a swimming pool, those kinds of things. They do smell very similar to what you think of as chlorine, kind of a metallic smell like chlorine. So that's kind of an overview. I want to show you one more kind of trend that you'll see. Sulfur compounds tend to have a really unpleasant smell, like stinky smell. So that might help you remember those two. And I guess that's it. So on the test, it'll be things like we mixed a reagent with sulfuric acid, and it produced a yellow-brown gas that turned blue litmus pink. And so I have just described this one. So I added sulfuric acid, I got these properties. What was my reagent? And the answer would be this. Or I could give you a list and say, which of these nonmetal products is basic in water? And one of them would be, the only one that's basic is this one. So anyway, that's what we're going to quiz you on. Let's go through these answers. So pay attention to what it's asking for, because it's not always asking for the nonmetal product. Sometimes it's asking for the reagent. So on the first one, it's easy because it's giving you the product and it's asking you what do you use to make it. And this one is our hydrogen peroxide. Okay, this next one, they're describing the product. And so what smells like rotten eggs and turns red litmus pink? Well, that was this one. And then your question would be, which of our reagents did we use to make that? And we used sodium sulfite. And this is multiple choice, so you'll be given, these to choose from. Okay, next, a violet vapor which looks brown dissolved in water and violet in hexane. That was our description of the iodine. But I just missed that. Again, it's asking which reagent is used to produce that. So if I want that to be the product, what did I use to make that? I used potassium iodide, so that's my answer. Okay, what do I use to make a gas with a strong pungent odor that turns pink litmus blue? Well, pink litmus blue, that means it's basic. The only one I had that was basic was this one. And what did I use to make it? I used this ammonium chloride. Okay, this one has a yellow vapor. And the one that was yellow was this combination. But if that wasn't enough for you, it also turns blue litmus pink, which says it's one of the acidic ones. So that would help as well. And so that was this one, potassium nitrite. For this last question, we've really already answered that when we went through the reactions. So you can tell mostly what you need to know is the nonmetal products and their properties. And it really does help if you kind of group those together to help you memorize them. And then be able to match them to the reagents.